So, can a star be cold? It kind of sounds like a trick question, doesn't it? I mean, stars are, well, they're the definition of hot. But the answer to this question isn't a simple yes or no. It actually gets into some really weird territory that challenges our whole idea of what a star even is.
But just think about it for a second. A star, the symbol of a blazing, fiery furnace in the cosmos, could it actually be cold? Your gut reaction is probably, no way. But the real answer? Well, it forces us to ask a much bigger question. What does it even mean to be a star in the first place?
All right, so the short answer is yes, but it's super complicated. You know the classic star, right? A huge ball of gas, fusing hydrogen in its core, pumping out tons of heat and light. But there are these other objects out there, these so-called cold stars that don't fuse hydrogen. Their surfaces can be colder than a winter day on Earth, and they barely shine at all. This is where our neat little definition of a star starts to completely fall apart.
So where do we even start looking for these cosmic weirdos? Well, astronomers have basically narrowed it down to two main suspects, two types of objects that could fit this very strange description of a cold star.
And here they are, our two main characters in this story, brown dwarfs and black dwarfs. Think of brown dwarfs as failed stars. You know, they had all the ambition to be a star, but they just didn't have enough stuff, not enough mass to really get going. And then you have black dwarfs, which are even stranger. They're like ghost stars, the cold, dead remains of stars that are so far in the future, they don't even exist yet. Yeah, you heard that right.
And this whole thing gets us to a really fundamental problem in astronomy. To understand these cold objects, we have to explore this incredibly fuzzy, blurring line that separates the biggest planets from the absolute smallest stars. It is a cosmic gray area, and it is filled with some truly bizarre worlds.
So what in the world is a brown dwarf exactly? Well, it's an object that's kind of caught in the middle. It's way, way bigger than a planet like Jupiter, but it never got quite massive enough to kickstart that hydrogen fusion reaction that powers a real star like our Sun. So they're not quite stars, and they're not quite planets. For a little while, some of the bigger ones can fuse a heavy type of hydrogen called deuterium, but that little flicker of fire dies out pretty fast.
Get a load of this. This is the estimated surface temperature of an object named WISE 0855-0714. It's the coldest known brown dwarf-like object we've ever found. -13 degrees Celsius, that's 8 degrees Fahrenheit. That is colder than a winter day in a lot of places on Earth. For something that was born like a star, that temperature is it's absolutely mind-blowing.
And see, this brings us right to the heart of the problem. If an object is literally freezing cold and it's not fusing anything in its core, can you really honestly call it a star? It's a huge debate among scientists, and it kind of forces us to look at another type of cosmic wanderer. They're called rogue planets, and they are exactly what they sound like. These are worlds that are completely untethered from any star. They're just drifting totally alone in the vast, cold, empty darkness between the stars. And they can be just as cold as that brown dwarf we just talked about. But how they got there, that might be a totally different story.
So there are two main theories for how you get a rogue planet. The first is that it was born a wanderer. It just collapsed from a cloud of gas all by itself, like a star, but it never got big enough to ignite. Some people call these sub-brown dwarfs. The other possibility is way more violent. It could have been born in a normal solar system, just like Earth, but then got into a gravitational tussle with its siblings and was literally kicked out of its home, sent flying into deep space. And the crazy part? For us, looking through our telescopes, it's incredibly hard to tell the difference between the two.
But believe it or not, brown dwarfs and rogue planets, that's only half the story. To find the real coldest star, we have to travel way, way into the future and meet that other candidate we mentioned earlier, the stellar ghost known as the black dwarf.
Now, before we even define what a black dwarf is, let's just get one thing crystal clear. Cold does not mean safe. If you could somehow teleport to the surface of one of these things and try to touch it, well, this is what would happen. The gravity is so ridiculously intense, we're talking hundreds of thousands of times stronger than Earth's, that you would be flattened into a film only a few atoms thick, instantly.
So what is this terrifying object? A black dwarf is what's left over after a star like our Sun finally dies. Its dead, leftover core is called a white dwarf, and it's incredibly hot at first. But then, over an almost unimaginable stretch of time, it just radiates all of its heat away into space until it becomes a cold, dark, dead cinder. that's a black dwarf.
Okay, quick but really important point of clarification. A black dwarf is not a black hole. They sound similar, but they're totally different things. A black dwarf is a solid object. It's made of this super dense stuff called degenerate matter, held up by a weird quantum force that stops it from collapsing any further. A black hole, on the other hand, is where physics just completely breaks down. It's a point of infinite density, a tear in space-time, where gravity is so strong that nothing, not even light, can get out. Two very different, very extreme things.
And now for what is maybe the biggest twist in this whole thing. Black dwarfs don't actually exist. Not a single one anywhere in the universe. They are purely theoretical. And the reason why is honestly one of the most mind-bending ideas in all of science.
To really wrap your head around why there are no black dwarfs, you have to understand the timescales we're talking about. And that means we need to take a quick little trip through the entire history and the entire future of the universe itself. So how long does it take for a white dwarf to cool down enough to become a black dwarf? About 1 quadrillion years. That is a 1 with 15 zeros after it. Let me put that in perspective for you. Our entire universe, from the Big Bang until right now, has only been around for about 13.7 billion years. The time it will take for the very first black dwarf to form is hundreds of thousands of times longer than the entire current age of everything that has ever existed.
Let's just look at this on a timeline of the universe. We are right here in what cosmologists call the stelliferous era, the age of stars. But that's not going to last forever. In about 100 trillion years, the last stars will flicker out. And that's when the degenerate era begins. The universe goes dark, and over those quadrillions of years, white dwarfs will finally cool into black dwarfs. And that's not even the end. After that comes the even more distant black hole era, and finally, the dark era, the ultimate heat death of the universe. So, black dwarfs aren't just objects of the future, they're objects of the deep, deep future.
Okay, let's pull back from the end of time for a second and come back to right now. What is all this talk about failed stars and rogue planets and these future stellar ghosts actually teach us about how we see the universe today?
I absolutely love this quote because it just cuts right to the heart of it. We humans love our neat little boxes. We want to label everything: star, planet, dwarf planet. But the universe itself, it doesn't work that way. It exists on a smooth, messy continuum. Nature really couldn't care less about our labels.
You remember the huge, fierce debate about whether Pluto is a planet, right? Well, this is the exact same problem we have with brown dwarfs. Is an object that's 10 times the mass of Jupiter a planet? Okay. What about one that's 15 times the mass of Jupiter and briefly fuses deuterium? Is that a star? Science needs us to draw a line somewhere, but we always have to remember that line is a human invention.
And this is where it gets really fun and speculative. Some scientists have actually theorized that an Earth-sized rogue planet could, potentially, sustain life. Think about it. It wouldn't be warmed by a sun, but by the geothermal energy coming from its own decaying core. It might be enough to keep oceans liquid under a thick, insulating layer of ice. A whole world of life, just drifting alone in the endless night.
So in the end, the search for a cold star leads us to all these strange objects that just refuse to fit into our simple categories. And it forces us to confront this really big idea. It leaves us with this fundamental question. When we create all these categories for the cosmos, are we actually discovering the rules of the universe, or are we just inventing our own? Something to think about.